lot to get through. So, all right, hi everyone. Today I'm going to be talking about Git and GitHub, which are a super essential thing that is like a really useful skill that you can just go into any research lab and just say, well, most of them, like all the computational based ones, and say, I know how this works, and you're immediately like, you have like a leg up on any potential competition. If you learn nothing else from this class, this is like the one useful transferable skill. This is going to be large. Yeah.
When I just anecdote here, when I was working at SpaceX this summer, I was working in hardware design, but the thing that they are most happy with, like by far, was the fact that I could use Git well, by far.
Yeah, all these like super complicated skills matter less than like knowing how to use this. Yeah. Also, so apologies for the one student we have who has also seen this lecture via ULab, but there is still some stuff here that I didn't get to say there. So not a total, like tune out a bit, don't tune out entirely. Before we get really into it, I want to talk a bit about projects. We are making project proposals due this Thursday. So the idea of this is, if you're still not sure, you can come to office hours tomorrow and Wednesday and see what you might want to do. If you've settled on reasonably a project idea and you figure you might want to partner for it, feel free to message on the Discord. Maybe someone wants to partner up with you. If you don't have a project yet and you're like really not sure what to do, please reach out to us as soon as possible. This is like the one deadline we're going to try our best to actually enforce, because the sooner you have an idea, the sooner you can like get going with it. So we do want to make this one on a pretty tight timeline. It shouldn't be that much work to write up the proposal once you've got the idea. We've had a few people submit already, so that's great. But yeah, try and get those in as soon as you can. All right. With that out of the way, I'm going to start talking about Git and GitHub and what these tools are and why we care. So this is a rough like sketch of what we're going to do, and some of these words are not going to make sense yet, but we will see what they mean. Okay. Motivation. Coding is hard. Like you've all seen this from like stuff we've done in this class that's been like pretty complicated at times, stuff you might have done in previous classes. And it just gets worse and worse as you get to more complicated use cases. What happens if I'm working on something and I accidentally delete some of the stuff I'm working on? How do I get it back other than like Control Z? What if it's like been a while since I last put the thing I wanted to get back in? What if I do something, I figure, oh, this doesn't actually work as well as I thought. I want to get rid of it, but then maybe I want to look at this later. And there's all sorts of like these complicated things to do with like the real life workflow. So one possible solution to that last problem is I could just like copy and paste my code into like a little text file somewhere. I go back and look at that text file later and I see like this is the fix that I wanted. But that just works like one time. What if I have like dozens and dozens of these? I need like a lot of different text files and like stuff to write down manually, and it's just, it feels like inefficient. And there's the issue of like I break something. I had something working before, and then I make a change and I didn't realize it was going to change this thing, but now this doesn't work anymore, and I'm just like, I don't care about the thing I was trying to do. I just want to go back to a version that worked. Like this is a really common thing when you're working on like projects for like more formal classes, where it's like, I actually need to show off some functionality. I got to that level of functionality, but I'm like, I want to add one more feature. Add one more feature, and it suddenly broke everything because I can't predict exactly what's going to happen. So what do I do then? If I don't have some history of what happened in the past, I'm just going to have to like bash my head against it or turn in something incomplete. And that just gets even worse when you're writing like code you actually have to depend on in the real world. So what do you do about this? One like easy thing you might try is just undo and redo, but I already mentioned some of the problems with this. And so here are some of the others. Like sometimes I haven't just immediately done the thing that I want to undo or to redo. Sometimes it's like really far in the past in terms of like command history, so I'd have to do it thousands of times. I may be losing something that I actually want to keep. And so if you're not using these kinds of version control tools, you would go back to the like paste this thing into a text editor solution, and that's just ugly. Another thing is like multiple timelines and collaborating with other people. How do I deal with that? How do I deal with, I've got two ideas for how I want to do something, and I want to try out both of them and see how they work individually without losing, like, I don't want them to interfere with each other, and I don't want to lose either one. Or what if I'm working on something, my friend's working on something else, we edit the same bit of code at the same time? So there's all of these problems that are like interrelated. It's very similar like setup to the problems that like Google Docs and Sheets and Slides fix. And you'll see some similarities to that, but this is in a bit more of a structured way. So I want like a decently like lightweight solution to these problems of keeping track of work I've done before. The general class of solutions to this is called version control systems. And the main version control system that everyone really uses in the real world, there's some others, there are some that are like proprietary companies. I know Google has their own like internal version of version control systems, of a version control system. And I know that like there are some other like general open source ones that are generally used. If Alan remembers the names of any of those, you can put them in the chat.
SVN, they're all bad. Don't use them.
Yeah, but basically no one uses anything other than Git. So Git is the thing that we are going to use, that we're going to learn. And so here's a bit on what Git means that I won't just read out because it's boring when people just read things out of slides. Yeah. But the big idea, the big idea, this one's entertaining. The big idea is I want to take snapshots of code at different times and be able to travel through time. Like imagine if you were just like taking a picture of something like in real life with a camera, but those pictures also let you like travel back to the past to that point in time. Do that for code, and that's what we're doing. It's like some sort of time travel sci-fi movie. Okay. Before we get into how any of this works, here is a bit of terminology. In general, we have version control operate on something called a repository, which is a directory where Git does its work. The more formal name for the like picture that's frozen in time that I just described is a commit. You know, like so you use it as a noun, like making a commit, but you sort of think of it in the sense of like I'm committing to something. I'm committing to this version of my code. A branch is like an individual timeline of like a sequence of commits. Like if I want to try two ideas or if I want to have two people working on the same thing, I can work on separate branches and then not have them interfere with each other, and they merge together later. And yeah, you are committing, as Alex says, you're committing to have any mistakes you've made preserved for the rest of time. Once I make a commit, it's immutable, just like, I was going to say, just like if I take a picture, there's no way I can change it later. But you know, you can now. Imagine like an old style camera with like photo negatives and stuff, where like I take a picture and that is just what it is forever. Okay. And another term I'm going to use is head, which is just like, think of it as just like an arrow pointing to wherever we are in time right now. So very often in Git, you're going to get messages that look like this. And so head refers to like where we are. Main refers to, it's like the default branch name. And this is like a unique ID for the particular commit. Yeah. Yeah. Commits are generally mutable, but like I've never tried it and have never wanted to, and I use Git fine. Like it's better, I think, to think about them, unless for like really advanced use cases, it's better to think about them as completely immutable. Okay. So let's start off with this idea of commits. Let's suppose I'm writing, as I did for ULab, a simulation of a double pendulum system. And this is like very similar. This is just a generic use case. You could put in like anything you want. So there's like several like phases to building this, right? I maybe like first want to build a general skeleton of like, here's all the functions I want to implement, and like write doc strings for them, and like think about how they're going to work a bit. And I'll have that all in a file called compute.py. And so what I do once I've written that first bit is I put that in a commit. I like take a picture of it, and I give it a message saying like created sim skeleton, and Git will give it this ID. And I can refer to this commit via this ID till the end of time. These IDs are like 60 characters long, but you can refer to them with like the first 6, and that's almost always unambiguous. Yeah. Then maybe I make some edits to that file, and I like write in a particular function. Then I take another picture, and I put in, and it's got another commit. And now this is the one that's at the head. Like this is the one that happened most recently in time. And now I get a completely new unique commit ID. It's got the same file in it, but at a different version with like more stuff in it than before. And so I put that on the timeline. This is the new one that I look at first now, and it points back to its parent. So this will make it really easy to like go back in time through the timeline of every commit knows what its parent was. So this also allows for like branching timelines. If I say, if I add in another timeline here, I can say there's this other commit here, and it knows if I go back in time, it's here. Whereas if I have it like keep track of stuff forward in time, well, maybe it's just the last one, and it doesn't really know what's going to happen in the future. Infinite things can happen in the future. Only one thing happened on your timeline in the past. So that's why I've got these arrows going right to left. It's a little confusing to look at, but not too much of a jump, I think. Yeah. And then I add in a second file. Yeah.
Oh, sorry, never mind.
Okay. Yeah, and then I add in a second file, take another picture, and now this commit has 2 files in it. And I give it another message. Okay, so that's the general idea of I build up a project bit by bit, file by file, and like with different stuff in each file. And periodically, this is something you as the user have to do. You have to like remember to do it. It'll get into your habit. Like you'll get into the habit of it fairly easily, I think. You will have to periodically like make these commits, and then this timeline will be set up for you. So once I'm at the end of these, like this description bit, I'll show you what that looks like in real life. Okay. How you make a commit is there's 2 steps to it. First, you choose what you want inside it, and that's done via the command git add. So on your terminal or whatever, you type git add, and then you list all the files you want in there. And if you just want it to be all the files, which is much of the time, you put in a star, and that just counts everything in there. How I like to think about this in the analogy of like you've got a camera and you're taking pictures, is you're like pointing the camera at something. Like taking a picture is useless unless I've like aimed it correctly and I know exactly what I want to take a picture of. But also just pointing it and not taking the picture is completely useless as well. Like I first specify what I wanted there, and then I take the picture. Yeah. Then the second one is you run the command git commit, and that looks like this. So I type git commit -m, meaning I want to type a message, and message goes here. You're technically not obligated to put in a message, but you always, always, always should, because it makes life easier for you and for anyone who is working on the same code base as you later. So like if you wanted to, for example, say, save some code you're about to delete, you should put in a message that like describes what that does. So later on, when you're like, oh, I wonder how I did that thing before I deleted it, you know exactly where to look because you've got the commit messages. Yeah. So here's a quick model of how that works. You've got these things in your repository. Repository, just a fancy word for directory where Git works, remember? And you add certain files. So in this, I've got files F1, F2, F3, but I only want to add 1 and 3. So I do git add on these, and they go to a staging area, which is like stuff that's about to be committed. And then I make a commit, and I've got the updated versions of 1 and 3, but even if there are changes to 2, they didn't get included. I chose not to take a picture of them because they're like not important or whatever. Like you make that decision. Okay. So that's the basics. This was a lot to internalize, so I'm going to pause for questions right now. And that could include just like go back up to this earlier diagram or something. seems like there aren't any. Aled, anything on chat?
Yeah, when we say it, oh, nothing from chat, but just one thing I wanted to clarify. When we say it,
Sure.
it goes to the staging area, it's not like the file disappears from where it is and goes to somewhere else. It's just that Git now knows and is tracking the changes that you've made to that file.
Yeah, good point. All of this is just a layer on top of stuff that is already done in files. And so Git knows about, like, all of this is stuff that Git does. Unless you make, like, unless you do like a remove or something via Git, Git doesn't actually like change anything about like what's happening in your directory. Okay. Yeah, for Christian's question, we are going to get to that at the end. I'm going to run through the theory and then we'll see it in practice. Okay. So how branches work. Like I drew above, you might want to have like multiple timelines. If I have like two ideas for how this is going to go, for example, if I wanted to say like in one version I've got animations, in others I've got static graphs. And for some reason those like conflict with each other or like are confusing to both have at once. Then what I can do is I can have two versions of this code base, one with animations in it and one with graphs in it. And they exist sort of independent of each other. At any given time in your directory, there's only one thing, but Git knows and is storing in the form of these like immutable commits, the version of your files from the other side. Like I can have this one be the active one, but Git knows about this one. And if I ask it to, it'll go here. And I can keep like adding on to the timeline here. I can keep adding on to the timeline here. They're not going to affect each other. So I think this is something I drew to show what a graph is, I guess. Okay. So that's the rough idea of that. So what I've been calling timelines, the formal name for them is branches. So this is one branch, this is the main branch. And this one is, I called it the graphs branch. You can call branches whatever you'd like. And I can keep adding on to them without them affecting each other, just as long as I'm aware this branch is where this is happening, that branch is where that is happening. Most open source projects run in a feature branching workflow, which basically means if you, like a user just joining the project, you want to add something to it, you create a new branch so that you don't affect anything on the main branch and you don't affect anything for like the actual users. You make a new branch, you add code to it, you test it to see if it works. Then when you're satisfied with it, you merge it back in. So you sort of unify the timeline. It's a little more complicated when you do it like interfacing with other people, but that's the general idea of why you would want to do something like this. Okay. And yeah, the command for creating a branch is git branch. So if I've got just this like single branch timeline, then if I make a new branch, then I have, so if I'm over here and I make a new branch, now I've got a new branch over here, and the head of this branch is at this point. So head graphs is here, main is here. And now if I make a new commit, on main, it would add over here. But now that I'm on this graphs branch, it's gonna add so that its parent is the one I was just at. So it's going to look like this. And so I've created this new timeline. And so I can go to, if I check out main, I'm back here. So right now I'm over here. And if I make a new commit, it's going to add on here. But I could type git checkout main, and it would take me back to this one. And I can do that like whenever I want. If I'm like, okay, I'm done trying out this experimental feature, I want to go back to like where everything works again, I can go back to main whenever I want. And you can have as many of these features as you like, of course. It's also possible to check out based on a commit ID. So remember how we said way up here, commits all have these unique like 60-digit long IDs. You can just type in the ID of one or like the first 6 characters of one, and you can also go back in time to that commit. Okay. In the interest of showing like practical things, I'm going to not go into detail about how merging works, but basically it lets you sort of merge these branches together. If I've got like a branch over here, I've got a branch over here, then I can type in like, let's call this one main, call this one other. I can type like git merge main other, git merge main other. I say like git merge the one I'm on, the one I want to merge with, and it's going to basically take like the newest files from main and the newest files from other. There's a whole like set of rules for that, like I described over here, that I can like go into more in office hours or something if you like, for like what it does to check which one is newer. But essentially it just takes like, if I've changed something in the one, then I take those changes. If I change something in the other, I take those changes. And changing something can include like deleting a file. But that's the idea of like merging after I've like improved the code base in some way. And then both main and other are going to point at this one, at this merge one. Okay. So that's essentially the very high level of how Git works. Now I want to talk about remotes and GitHub. All of this works just locally on your own machine. But I don't only want to work on my machine. I want to be able to share my code with the world. So like I want other people out there in the world to be able to use my code. And also, in case something goes horribly wrong with my machine, I want backups. GitHub is a website that supports this, and it pretty much works like Google Drive, but in a way that's like aware of all of the stuff that we just talked about with Git. So you should also periodically, if you're working on Git with GitHub, run this command: git push origin main, or like whatever branch you're working on, and origin is a specific thing that says like this particular GitHub repository, and that'll send your code there. And if on the flip side you're getting code from somewhere else, from like a particular repository on GitHub, you can do git pull origin main. And that's essentially how you're going to interface with GitHub through your local code base. Okay. So that's enough theory. Let's see how this actually works. Any questions on the theory stuff before we get into that, though? Just gonna open up a terminal and see. Oh yeah, GitHub recently changed something like last November or something. They changed everything from master to main. Master was considered sort of oppressive terminology, and there's lots of good reasons to make that change, but it does take a little getting used to, I agree. Yeah, so let's see. I forgot to start screen sharing. All right, is everyone seeing my terminal? Let's blow that up, actually. Oh, suddenly I just lost my like Zoom chat window. That's weird. I'll just keep an eye on it.
Will do.
Yeah. Okay. Yeah, there is a way to retroactively change it though. There's like a project that someone I know created to just do that for all your repositories at once. Anyway, getting on with the point.
It is not.
So I'm in this directory, and this is all the stuff that we've put together for this class. I'm going to make a new one, GitHub test. Okay, so I'm in this new repository. There's nothing in it. It's called GitHub test, and I want to start a new Git project. So what I do for that is git init. Let's just make a text file with make new is just, oh, I didn't program that yet. That was an alias I had on my last machine. It's touch a.txt. So wait, do you remember if this is the right syntax? I didn't do a lot of
Yes, that
bash
is correct. That is correct.
Wait, what happened?
Do you have mismatched quotes?
I don't think so. I'll just do this from the text editor. Sorry about that. Anyway, I'm going to add the words hello world, which is just like the common like CS thing you do to start with over here. And if I do now cat a.txt, you'll see this. You'll see this extra percentage sign because I did not add a new line at the end, but don't worry about that. So now I've got this line of text here, and I want to share this. So first of all, I want to track this forever. I want the record to reflect forever that the first thing I did here was open a text file called a.txt and type in hello world. So I'm going to first add.
No, run status first.
Oh yeah, that's also a good thing to show. So I can always do this. If you're ever like unsure about what's going on, I can do git status and it'll tell me what's happening. So one thing is this is on master. I guess I haven't updated in a while. Oops. But yeah, if you just made a GitHub repository, you would see main over here. No commits yet. Untracked files, meaning like stuff that's in your directory but that Git doesn't know about, a.txt. There's nothing added to the commit, but there's untracked files present. So it's saying you should probably use git add and track this. Like I think the git status messages are generally pretty like reflective of what you want to do. They're pretty descriptive. And like the common errors are common enough that if you Google them, there's like whole websites devoted to like, these are the most common Git error messages and what you should do to fix them. Anyway, let's now add it like they're suggesting. Okay, so this is just specific to my terminal, but I got a little plus here. That seems good. So let's run status again. And now I don't have this message about untracked files anymore. Still no commits yet, but it's saying there's a new file, a.txt, and it's in green now. So that seems nice. And what do I need to do next? Bit Dora the Explorer of me, but remember this was a two-step process of I add and then what happens. Okay, incredibly Dora the Explorer of me. I'm answering my own question. I commit. So let's see, let's type in git commit, and I put in a message like said hello. Like I describe what happens there a little bit. Okay, and now I have a new commit that says said hello in it. And it's told me I changed one file and one line of text got inserted. Yeah, does dot do the same as star?
Yes. Well, I don't know. Star should glob to all the files in the current directory, whereas git add dot will glob to, it's just like recursive. You add a directory, but also git add star should glob the folders in that directory, so it should also be recursive. So basically, yes, probably.
Oh. Yeah.
Terminal globbing is weird. Don't worry about any of those words. Just yeah.
Yeah, if you've got a bunch of files and you don't want to individually add all of them, like git add a.txt, b.txt, c.txt, if that's a lot to type out, then you could just do git add star. And that would be the same thing. Yeah. Okay. And now if I want to see what's going on, I can run git log. This is a useful thing. It tells me like the entire history of commits. So this is like the really long ID I was talking about before. I'm going to note down the first 6 over here. It tells me, hey, I made this commit. It's like the last commit on the master branch right now. I said hello in it, and this is when I made it. These are all useful things that you might want to look up later. If like, okay, I remember I was working on this like last Thursday. What was I doing last Thursday? What did I save? These are really useful things to look for. And there's also like, this isn't part of Git proper, but there's this nice thing that does that in a sort of compact form. Logline, there's like a little like thing you can add, thing you can run one time to get you that functionality. Anyway, I'm going to make a change here. I'm going to add like the second version. And let's
You could
see
use
what I
nano so we can see the.
You could use what? Oh yeah, I could use Vim. Yeah. I forgot that as a thing until right now. Yeah. Thanks. But anyway, I just changed the text file so that it says this. It's now got the second version there. Exciting. I'm going to try and rush this. So I'm going to do the same thing again. Git add a.txt, git commit second version. And now it tells me I changed one file, 2 insertions, 1 deletion. That's interesting. And so I can do git log, I'll just log line. And then now let's say headmaster doesn't point at this first one anymore. It points to the latest one I just did. And if I want to go back, I can do git checkout. Whoops, I didn't copy the right thing. But I can git checkout to this commit I made before. And it'll give me a whole warning about detached head state, but don't worry about that. I can get back later. And now if I do this, it'll just have hello world in it. But then I can always go back to wherever the head of master is. And now I have the second version. So that's very broadly how it works. But that's just like a toy example that I made up. How does it work like in the real world? So let me show off our course website. This has like a bunch of folders in it. Like most of these are like auto-generated by something that like makes our website for us if we just edit a few markdown files. It's like a common template you can look up. But what do we do in it? So let's run git logline again. And you see the benefit of logline here, where just if I were doing log, there'd be like a lot to scroll through. And so this is a little nicer just to look at. Doesn't really matter. So now I see all the changes that I made, all the changes that Alad made, and when they happened, and what happened to them. So, you know, you can see that we're both not necessarily the best at naming our commits when it's just like for the two of us, and we know that it's like probably okay. But over here, like I'll be like homework 3 release, actual homework 3 release. So I know like if I want to go back to something I wrote for the homework 3 release, I want to look at like the commits around here. I want to see what Alad was up to 2 months ago fixing homework 2. I'll see that if I go back to this commit. You see this sort of weird structure here that happens when we make another branch and we start working on that other branch. So over here, it looks like we were working on this other branch here, and then we resolved it and we moved it back in. So you see sort of the whole history going way back to like the start when Alad made this 4 months ago of what's happened with this website. And if I want to go back to any state before it, I can do that. So that's a really cool application of it. Okay, so that's what it looks like on the terminal end. Let's take a look at what it looks like on the GitHub end, because that is a lot nicer to look at. So wait, this is, yeah, so this isn't the GitHub for our course website. Let me show that off first. This is another thing I want to show because it has some more features that I do want to talk about. Okay, so over here, you have this really nice interface. So this is, you can see this and start making these if you make your own GitHub account, which you're required to do for homework 5. And you see this whole like set of folders and stuff, like pretty similar to how it is on my computer. It gives me like the commit messages and like how far back they were edited. So these are the commit messages for like the last time we edited these things. So it looks like the last time I updated docs, which is where we put like the stuff we write, was 2 days ago. And it looks like I edited that. Whereas the last time we edited public was a commit 4 months ago called worky work that I assume Alad wrote. So over here, I can click on this and I get like a nice visual representation of the same commit history of like who did it and when. And over here, I get this little check mark, which that's not present in all repositories, but it's an extra thing we added on to actually make this website. It's saying like, where we have some code that tells this repository to actually make the website whenever we update it. And so that making the website process worked. So most repositories aren't going to have that. It can tell me like what mix of languages this is written in, which is always really skewed to whenever Jupyter Notebook is there, just because there's something off about how Jupyter Notebooks count lines. So just from like the few homeworks we've had in Jupyter Notebooks, it's like dominated by them. So if we had issues, you'd be able to put them here. There's like pull requests for if like someone in the outside world wanted to edit it and we were like, hold on, I want to see what you're doing to my website first. Insights where we see oh, you just haven't committed in the last week. Yeah. Oh, you haven't committed in the last month. Oh, here, contributors, and there's just kind of like interesting data you can see. There we go. So you can see like Alad's added this many lines and deleted that many lines. I've added that many, deleted that many.
Yeah, I've never been able to figure out what Pulse does, but yeah.
Pulse is just kind of weird. Anyway, so there's just all kinds of things you can see about this. And so this one's private of like this repository, like only Alad and I can see it. But let's go over to this project, which is a public one. You go to this link and you write it. I wrote this as a project for a class. They store images as text. Interesting. Yeah, I wrote this as a project for a class, and I'm still working on it a bit this semester. And this is more of like the kind of thing that you would see for like a real project out in the world. So it's got a README file of like explaining what this does, and usually there'll be like minimal working examples of code. It's written entirely in Julia. These are my group mates. I made an actual like release of it because I had to register it as a Julia package. And so here I can go into like, there's the source files. I can go in and see this is what a source file looks like. And once again, I can go back through my commit history and see like who's done what and all the stuff I've done in the past.
You can also click on those commit IDs and browse the
Oh,
file.
yeah.
From that
oh,
tab.
yeah. And you can see individual changes. Like the last thing that I changed when I was trying to fix something earlier today is this. There's this function in here, which had this return n/3 thing, and I changed it to this. I don't know why on a code end, but like I can go back just from GitHub and see. I can go back in GitHub and see I removed this one line and I added these like 8 lines or whatever. And I can do that for any commit. I can go back like to November 30th when I made a commit called profiling. What was that? It was making all these changes to this file. I took this out and I changed it to this. Took this out and changed it to that. So you have a really nice view of like how this whole thing's evolved over time. Okay. Well, I've got about 10 minutes to talk about the last couple of things I want to talk about, which are why does this project, which is not making a website, have a check mark on it? But any questions before we move on to that? Oh, it's also probably worth me showing you what my local version of this project looks like. So I use Visual Studio Code, which is a fairly nice editor for this sort of thing. And sorry, it's loading. Yeah. So I've just got this in like a regular folder in where is it? Like there it is. Okay. Wait. Do you see my VS Code window?
Yeah, we can see it.
Cool. Okay. So it looks like this. I've got like all these same files over here. So one thing that I like might not have there, I forget if I have it or not, is this data folder. Like sometimes you don't necessarily want to push it, so I'll just like avoid adding and committing that. Like, so what that looks like is here, I've got a bunch of folders and like code files within them. And I've got a bunch of tests there are little functions I can run that will throw an error or like pass just fine. And so whenever I like make changes to this, let me just make a random change just for an example. I'll like add a variable called C, set it to 3, or like I'll change like power to 20 over here. And what that'll do, I hope this doesn't actually break my code. Wait, let's change it to 5. That'll definitely work. So what I'll do over here, VS Code has a little thing over here that handles it, but I'm not going to go through that this time, is I'm going to see what did I just change? I changed something in my test directory, test random.jl. So I'm going to git add test random, or I could have just done git add test or git add star. That would have worked too. Git commit -m, and I'm going to explain what I just did. Change max power for commit demo purposes. I'm probably going to get rid of this commit later because I don't want this in my actual history, but who cares? So in this case, it's called main because I set this one up right. But anyway, now I'm going to do an extra step that I didn't do in my like basic demo, git push origin main. And that is going to send this little change I made to GitHub. So what did that change on GitHub's end? But switching between all these screen shares is really strange. Okay, are we back at the GitHub?
Yes.
Nice. Okay, so I'm going to hit refresh on this. And now there's 102 commits, not 101. And it's got my change over here. Change max power for commit demo purposes. I did this 40 seconds ago. It's got a new ID. Everything's good. And you can see, if you go into my commit history, you can see exactly what I changed. This 10 is now a 5. Okay. Now, we've got about 8 minutes. Oh, too far back. Oops. There's also like a timeline where you can see what your friends are up to in Code World because GitHub's like social media now. Okay. Anything standing out to anyone here that wasn't like it was before?
It's an orange circle.
It is an orange circle. What's up with that? Some checks haven't completed yet. So I am using in this project what's called continuous integration, and that's enabled through this service called Travis CI. What that is you saw before that I have a bunch of tests. I really hope these actually pass because that's just nicer for a demo, but whatever. Basically, when I've got a really big code base, there's like too many tests and stuff to run to really keep track of. If I'm changing something, I want to make sure that change didn't break everything. So what I've got set up here is called continuous integration. It basically tries to set up, I can give it like a task to do. In this case, I've given it the task of run all my tests, but it could also just be check that it all compiles or something like that. Whenever I make a commit, this extra service, Travis, is going to like tie into GitHub, and GitHub is going to tell it, hey, I just got a new commit. Let's check if it works. And so this is what it's doing. It like makes a new like virtual machine and it tells me like exactly what it's doing, the versions of everything that's using on this virtual machine, stuff that I can like look up individually. It's installing a bunch of Julia packages now and seeing if all of those work. It's adding a bunch of Julia packages. Just like it's running everything it needs to run my code later on. And then it's going to run all my tests. And once it does that, it's going to give me the little green check mark. So this is so that I can be sure that when other people try to run this, when they get my code from GitHub and they try to run it themselves, it's going to work because I've checked that it works not just on my machine and not just once and not manually. There's also an extra service called CodeCov that I have tied in that I'm not really using because I have like 40% coverage. But ideally in like a big mature programming project, these checks take several minutes because it's just quite a labor intensive thing. But like you saw it before, if it's the little check mark, it's still trying. I also have a service called CodeCov or CodeCov, I'm not really sure how you say it, which essentially checks what percentage of my code have I actually covered with tests. Ideally, in a big mature software project, you have close to 100% coverage. If there is a line of code there, there is a test that's going to check that it still does what it's supposed to in the end. And so setting these up is surprisingly simple. I just had to write this extra file that's like a few lines. I had to say it's using Julia version 1.5. I want to use CodeCov. This is the line of code that I want to run after my Travis check has successfully passed. And so when I ran this earlier today, it passed just fine. Code coverage and continuous integration passed. Oh, I have 76% coverage. It's way better than I thought. So if you go on like a really mature project, like, Alec, give me one.
Go num.
Go num, like that?
Yeah.
Okay.
Yeah.
Yeah, if I go on a really mature project, I'm probably going to have a bunch of badges. So let's pick this one here.
I think they have code coverage.
Yep, most big projects have code coverage. Like
their coverage is actually not that great. That's
interesting. Yeah, I didn't even try to get good coverage, and I have 76%, and they have 77, and I assume they've tried. So sucks to be them, I guess. Anyway, there's a bunch of things here that like give you like broad information about it. It says, hey, I have this continuous integration thing, and it passes, and I can go here and I can see the exact job that they did. They tried to build this code on a bunch of virtual machines, and it worked. So that works. Build works on a couple different types of machines. I have code coverage here. I guess this is documentation. It usually says docs.
Yeah.
Yeah. Like another normal one of these badges is linked to a separate documentation page, and we're going to have a whole separate day on documentation. Go report. I'm not familiar with this one. But the idea is there's a bunch of badges that, like, before you even go into it, will tell you like some basic information about this repository, about how certain can you be that if you try to run this on your machine, it's going to work, and that it's hard to break something without it being caught by our tests. So these are sort of all the hallmarks of like really good code design and usage of version control and these advanced tools. I would say like Git and GitHub are definitely more essential to know about than Travis and CodeCov. But if you are ever writing anything like reasonably like open source or contributing to a big software project, which is a direction that I see a lot of astronomy going in the next few years for sure, then you will want to know about these. And because like good software engineering practices, or even these really simple ones of commit early and often and set up continuous integration so that you have stuff automatically check for like things breaking, and make sure you cover as much of your code as you can, that's going to make your life so much easier. When you're writing something complicated and you can't keep track of it all in your head, you have things to do it for you. Okay. The last couple minutes, I want to go back to my repository and see if my tests passed. So let's go here. They did. Nice. All right. That's all I wanted to talk about. That was a lot of ground we covered in not a lot of time. And no doubt when you do this for homework 5 or for anything else you do in the future, you'll probably still have questions. But if you've got any now, we're happy to take them.